need to record this period because I didn't do it last period. So, four formulas. We'll work through them, talk about them, and then we'll do some examples. But some variables that apply to all of them. A is the final amount. A for amount. But even better than thinking about A for amount, I think of A as the after. A is the after amount. If you invest some money, how much do you have after so many years? P is the principal, which is the beginning amount. But there's an even better word that means beginning that starts with P. So English people, what prefix means before and starts with a P? Pre. So I think of the P, officially it means principal, but I think of it as the pre. So prefix. T for time, R for rate. Although on the R, remember, be careful because percentage to decimals, right? You got to move the decimal spot 2 places. You've done that before, just a reminder. Let's do one more. So 3.7%, what would that be as a decimal? 0.037. So not hard. The big thing is just remember to do it. All right, for one formula, we also have n in the formula. This is a kind of a weird variable. This represents the number of times per year that an investment is compounded. So compounded monthly means n is 12. Compounded yearly means n is 1. And so it won't ever tell you what n is. You just have to use your knowledge of the calendar. So if it's compounded quarterly, what would n be? 4. Because there's 4 quarters in a year, like there's 4 quarters in $1 and 4 quarters in a football game. How about weekly? What would n be? 52. Good. So here's the 4 formulas. Compound interest formula versus continuous interest formula. So the big deal, or the giveaway to use the continuous formula, is the word continuous. Like the problem will say continuous in it somewhere if it wants you to use this compound interest formula. All other principal rate amount problems is this formula. It's got a plus and a minus. You don't ever use both, but it's easy to know which one to use because these are growth and decay problems. I guess we should say growth or decay problems. So I think it makes sense that if it's growth, use the plus. If it's decay, use the minus.
Do we have to memorize these?
Do we have to memorize these? No. How did they know that you don't have to memorize these? Because I said it already. All right, the half-life equation is the easiest one to identify. It might be hard to memorize if you had to memorize it, but it's easy to identify because how will you know that this formula is the half-life formula? Because there's a 0.5 in there. So the half-life formula is the formula that has a half in it. So usually that's not too bad to figure out. People get the T and the H confused for the half-life formula. T is time, like the time of the experiment, or the H is the time required to decay by half. Usually we're looking for how long did it take. H is like a property of the material. Like I think carbon's half-life is like 12,000 years. That's how they do carbon dating. So if there's half as much carbon in something as there was originally, then you know it died 12,000 years ago. So H is the time required to decay by 50%. They will usually give you H and ask for T. All right, number one. $5,000 is invested in an account which pays 3% interest compounded monthly. That's a big hint as to which formula we'll use. What is the value of the account in 10 years? So I would say job one is figure out which formula to use. But if we're compounded monthly, that would be the one that has an N in it. So let's write the formula. And then let's figure out which variables we know and which ones we're looking for. So A and P and R and N and T. There's a lot of letters in this problem. So A is the amount. What's the amount? Or A is the after. Is 5,000 the after? So after is what we don't know. After is what we're looking for. What's the P? What's the pre? 5,000. What about R? 3%, which is 0.03. N has to do with how many times per year we compound. Monthly means 12. And T is 10. So let's fill in the pieces. A equals 5,000. 1 plus R over N. Whoops. 0.03 over 10 times 10 to the 12th. So either get your own calculator out or borrow one of mine. Oh, it's over 12. You're right. You're right. Thank you. Over 12. Again, use this time to type it in the calculator. It's so frustrating when you get to test day and someone is like, how do I put this in the calculator? I'm going to be like, do it like we did in class, knowing full well that that person that's asking that didn't do it in class, but that was their choice. So get a calculator so you make sure you know how to put stuff in. I'm not going to call him out. If he wants to ask me on Monday and have me tell him too bad, then that's his choice. 5,000 times 1 plus 0.03 over 12 to the 10 times 12. 6,746.77. That says 10 times 12. N times T. The one nice thing about word problems is that your answer should make sense. Like, I know we're not financial experts, so you don't really have an idea of if you invest 5,000 for 10 years at 3%. But if you'd gotten $6 million, hopefully you'd realize, wait a minute, I'm not really expecting to make $6 million off of a $5,000 investment.
I got 173,000.
Yeah, if you invest 5,000 and 10 years later you have 173,000, hopefully you realize, wait a minute, so I'm either cheating on my investment somehow or I made a mistake.
Oh, I didn't divide it by 12.
Questions on number one? Number two. How much money was invested at 2.45% interest, compounded continuously? There's an important word. Continuously. If the value of the investment is worth $2,000 in 9 years. So continuously is the PERT formula. Some people describe it just because that's the the word it spells out there. Continuously is the PERT formula. So AP, E is not a variable. E is a number, like it's in the calculator, 2.7 whatever. So I don't have to worry about what E is. Let's figure out what we know and what we're looking for. A is the after. Do we know the after, or is that what we're looking for? We know what it is. This is the 2000 is the after. That's what we end with. What's the P? Is that what we're looking for? That's what we're looking for. Rate 2.45, so 0 or 0.0245 for 9 years. So 2000 equals P, E to the 0.0245 times 9. So how do I get P by itself? Well, right now it's P times.
Divide it.
So let's divide. Right, this is P times E to all that stuff. So if we divide both sides by E to all that stuff, and this is where some people would like the fraction bar on their calculator. So alpha y equals, if you like the fraction bar, if you need the fraction bar.
Way better.
On the E button, there's two buttons that you can get E from. On the divide button, it's just the E. On the natural log button, it's E raised to a power. So because most of the time we use E raised to a power, that's why it's on the calculator. So it saves you a little bit of time if you use that one. If you use the other one, it's fine. E is above the natural log in the bottom left. 0.0245 times 9, 1,604 and 24 cents. Well, it's multiple choice, so it'll be all right. Number 3, how much time? So already I know I'm looking for time. Will it take for a $3,000 investment to double if it compounds every 6 months at a rate of 8.5%? So every 6 months tells me to use this formula. It asked me for time, so I know I'm looking for time. That means I better know A and P and N and R. R equals 0.085. What does N equal? N is how many times per year we compound.
It's 2.
So it's not 6. It's trying to throw you off by putting the 6 in there, but if we compound every 6 months, that's N equals 2. How about the A and the P?
3,000. No,
6,000.
6,000.
3,000.
Well, I'm hearing 3 and 6, but which one's which?
3,000 is P, 6,000 is A.
3,000 is what we begin with, and then if we double it, it would be 6,000.
Wait, how do we know which equation to use again?
Because it compounded every 6 months rather than compounded continuously. There's 2 compounding interest formulas. One of them we use for continuously, one of them we use for monthly, quarterly.
Should be the first equation we got.
Yes. And we're looking for time, so let's fill in everything we know. And this is going to take a little bit more work than those others. this is now like some of those problems on the quiz and homework. We've got to solve for t. We get t by itself. What do you want to do first? Let's divide by 3,000. So 2 equals 1 plus 0.085 divided by 2, which you could put that in the calculator and get a number for that, but I'd rather just leave it alone for now. Alright, that was good. That was helpful. Simplified things. What do you want to do next?
Square root.
I mean, that would fix the 2, but there'd still be a t up there. And the t is the main problem. How do I get a variable out of the exponent? I can't divide it by t. If I log both sides, the reason we would log both sides is because that 2t can now become a coefficient. So natural log 2 equals 2t, natural log of all that other stuff. Now, I know you think that's more complicated, and I guess it is, but now I have t as a coefficient rather than an exponent. In fact, I have 2 times t times natural log. So if I want to get t by itself, let's divide by all the other stuff, everything except t. I want t to stay, so let's divide by 2 natural log . So on the left, on the right, we're left with just t. And now I've got a definite calculator problem here. And I usually don't use the fraction bar, but for something that's that ugly, I probably would. Natural log 2 in the top. 2 natural log 1 plus 0.085 over 2. 8.327 years. This time's always going to be in years. And that seems reasonable. $3,000 to double in 8 years. Again, if we got 0.0003 years, then we know something's up. If we got 1,000 years, hopefully we would know something wasn't quite right. So check your answer to see that it makes sense. Alright, this is what the test is going to look like. It's going to have the equations at the top of the page, but not labeled and no variables labeled. Just do you know when to use which and how do we use them? Number 4. At what rate does an investment of $4,000 triple? At what rate? You're saying the second one. How do you know it's the second one? Continuously. Again, continuously is the giveaway to use the second one. So the first one is quarterly, monthly, yearly, every 6 months, weekly, daily. The third one is if it's growth or decay and it doesn't have monthly, weekly, daily stuff in there. And the last one's the easy one because there's a half sitting in there. Alright, so number 4, continuously is the giveaway to use the continuous problem. At what rate? So we're looking for R, which means we're supposed to know the rest of them. A and P and T. So what's the A? 12,000, because the investment is 4,000. That's the initial. That's the pre. If we triple that, we'll get to 12,000. So we started with, we pre at 4,000, and the time was 10 years. So 12,000 equals 4,000 e to the 10t. What do you want to do next?
Wait, is it not the right thing?
Oh, you're right. 10 is the t. Yeah, I labeled it the wrong thing. 10r, because r is what we're looking for. Then yes, let's divide by 4,000. So 3 equals e to the 10r. Natural log both sides. Again, why are we natural logging both sides? What does that accomplish for us? It gets that exponent down front. And I really like this one because the natural log of e is 1. So r will be natural log of 3 over 10. So r equals 0.10986. But if I want that as a percentage, probably 11%, or you'd be rounding it to 10.99%. And it didn't specify how many decimals, so.
Are we always going to use decimal places, or is it going to tell you?
It will tell you, or it's multiple choice, so you'll just go with whatever the multiple choices are. A dead tree in a forest is deteriorating at a rate of 4.27% per year. Deteriorating. So which formula are we going to use if we're deteriorating? Decay, right? It's another word for decay. And we're deteriorating, so 1 minus r to the t. The tree weighs 6,359 pounds today. In how many years will it weigh just 100 pounds? Let's see, so the after is 100. The pre is 63.59. The rate 0.0427, and the t is what we're looking for. I feel like this is going to be a long time, right? To go from 6,000 pounds to 100 pounds at 4% per year. Anybody want to take a guess before working the problem? That's a very specific guess. Have you done the problem already? Oh, that I did do the A and the T backwards. This was never going to work this way. Let's see. I labeled them right and then put them in the wrong spot. The pre was the big one because we're deteriorating. What do you want to do next? Yep, divide by 63.59. So there's a couple options here. I mean, you don't have an option as to what you do. You're dividing. But some people will just leave it as that. They're like, well, fractions are bad. Well, yeah, but do you want to write out whatever that decimal is? 0.015725743, but you want to be accurate, so you don't want to just round it. So it's almost preferable that you leave it as a fraction because it's perfectly accurate, And it's probably less writing than carrying all of the decimals around. All right, we're getting close, but this is the key step.
Could you make like an equation and put it into the graph and then get a table and then you can see like
That's it.
3 years through or whatever?
I mean, you could, but you wouldn't get exactly what we want for t if you did a picture of this problem. What do I want to do next? It's natural log because that'll get the t out of the... And again, the 1 minus, you could subtract that in the calculator if you want, or you can just keep carrying it around as 1 minus 0.0427. Okay, natural log of an ugly number equals t times natural log of another ugly number. But we're about to go to the calculator. What do I need to do to get t by itself? Divide. So yeah, this is going to be ugly, but the calculator can handle ugly. I'm using one fraction bar, but you could use as many as, well, I guess you could use 2 different fraction bars in this problem if you wanted to. So in 95 years it would decay. Guess that makes sense.
How does it affect our weight?
They were surveying like 1,000 years.
Yeah, but there aren't any trees laying around that are 1,000 years old.
And
I mean, yeah, unless they're petrified, but then they're not decaying. They've done some other chemical process. Let's skip number 6. 6 is very straightforward. Let's do number 7. How long does it take? So we already know we're looking for t. The 100 milligram amount of radium to decrease to 5 milligrams. So half-life formula. So the after is 5, the pre is 100. Oh, this is a little bit tricky because the half-life is given in problem 6. The half-life of radium is 1,600 years, so that's H. That means it takes 1,600 years for radium to decay by half. So 5 equals 100 times 0.5 to the t over 1,600. What do you want to do first? Divide by 100. 5 divided by 100. You can leave that as a fraction, but 5 divided by 100 is easy. That's 0.05. What do you want to do next? No, because t's up in the exponent. Let's log it to get it out of the exponent. Anytime a variable's in the exponent, we're going to end up logging both sides to fix that exponent. What do I do now to get t by itself? Multiply by 1,600 and then divide by natural log of 0.5. $1,600 Natural log 0.05. Careful with parentheses. Natural log divided by 0.5. 6,915 years. 1,600 times natural log 0.05, close parentheses, divided by natural log 0.5. This last is just kind of interesting. The half-life of uranium-235, which is used in nuclear power plants, is 700 million years. And that's why some people are hesitant to use nuclear power, because it's awesome, but then your waste material doesn't decay to half for 700 million years. But you're right, the waste material is really small. Put it in a protective layer and bury it and be done with it. I mean, is that better than burning coal or gas?
Yeah.
Probably.
Depends on how protected that layer is.
Yeah, you make sure your layer is very protective.
Oh, here.